Alright guys, here's your notes on the impulse momentum theorem. On the left side of the page I wrote the equation that is the impulse momentum theorem. It's just one line. Ft is on the left side of the equal sign, that's force times time, equals on the right side of the equal sign, mass times these two variables in parentheses, that is final velocity, Vf, minus initial velocity, Vi. Alright. So here I listed the variables and all of their units. Force is newtons, contact time, that's T, is seconds, mass is kilograms, final velocity is in meters per second, and so is initial velocity. Alright. Just going to shift that down. Alright, and we're going to do an example problem with the impulse momentum theorem. Alright, so it says a softball, and they give you a mass, 0.19 kilograms, is thrown to a catcher. Alright, the ball is thrown with a speed of 20 meters per second, and it slows down when it hits the catcher's mitt, taking 0.2 seconds of contact time to slow to a complete stop. Alright, so and they ask you what force stops the softball. What force is applied by the catcher's mitt to stop the softball? So what we want to do is read through the problem and list our givens before we plug it into the equation. Alright, so we see that the mass of the softball is 0.19 kilograms. That's our first given, right? And our second would be that it starts out with a speed of 20 meters per second. That's the speed before it hits the mitt. So that's going to be our initial velocity, right? We could also list the final velocity. It's the speed after it hits the mitt. So how fast is the softball moving? Just think, after it hits the mitt. Well, it's not moving at all. So it has a speed of 0 because it comes to a rest after it hits the mitt. Alright, and the last variable gives you is the 0.2 seconds, and that's the contact time. So that's T. Okay? Let's list our impulse momentum theorem here on the side before we plug in to solve for force. Force is our question mark. Alright, so F times 0.2 seconds equals 0.19 kilograms. And in parentheses you got Vf, that's 0, minus Vi, which is 20 meters per second. So that's how you plug in your givens to the formula. Alright, the first thing I would do is 0 minus 20 gets you negative 20. Then I would drop everything down and rewrite it. And the second thing I would do is do the 0.19 times the negative 20. Alright, do that on your calculator. 0.19 times negative 20 is negative 3.8. On the left side you have force times 0.2 equals negative 3.8 on the right. And our last step to get force will be to divide both sides by 0.2. Right. So the force, when you divide both sides by 0.2, is equal to, oh wow, a negative. Why is that a negative? Huh. Negative 19 newtons. Why a negative? Well, just like friction was a negative force and slowed down objects, don't be surprised when you get a negative force applied by the glove, because what's the glove doing to the softball? It's slowing it down. So you're going to get a negative force when objects are slowed down. Alright, so next, what impulse stops the softball is the second question they ask you. As you know, impulse is equal to force times time, right?
You have two.
So to calculate impulse, do negative 19, which you just solved for, negative 19 newtons times 0.2 seconds, which is the contact time. And you get negative 3.8. That That's showed up before. We've seen that before. And that's not an accident. It showed up in our last problem we did. Right. So our unit for impulse is Newton seconds. So don't forget to label that, right? So why did we see that number before? Well, it showed up on the right side of the equation. And the right side, mvf minus vi, is also equal to the left side, which is f times t, or impulse. All right.